Let us see now axiom 6.3 and 6.4. Let us see axiom 6.3. See, I have drawn two different diagrams, figure 1 and figure 2. Figure 1 when there are two parallel lines, and figure 2 when they are not saying anything about parallel lines. We have to prove that lines are parallel. See, axiom 6.3. If transversal intersects two parallel lines. So I have drawn AB is parallel to CD and PS is their transversal. PS is intersecting AB in point Q and CD in point R. If transversal intersects two parallel lines, then each pair of corresponding angles is equal. ओके, अगर ए बी और सी डी पैरेलल है एंड पी एस उनकी ट्रांसवर्सल है, then we are getting how many pairs we have studied earlier. We are getting 4 pairs of corresponding angles and each pair is equal. I have written here, okay, all the pairs. PQB is equal to QRD, PQA is equal to QRC. Similarly, BQR is equal to DRS and AQR is equal to CRS. So this is axiom 6.3. So it speaks about two parallel lines and the pairs of corresponding angles. Let us see now axiom 6.4. Okay, if transversal intersects two lines, okay, two lines. 6.3 में पैरेलल लाइंस की बात कर रहे हैं, यहाँ पर टू लाइंस, इसलिए मैंने इस तरह का डायग्राम ड्रॉ किया. इफ अ ट्रांसवर्सल इंटरसेक्ट्स टू लाइंस सच दैट अ पेयर ऑफ करस्पॉन्डिंग एंगल्स इज इक्वल, then the two lines are parallel to each other. So this is for what? For proving the lines are parallel. Okay, you can see here diagram figure 2. AB is not parallel to CD. I have not drawn it, purposely I have not drawn, and PS is the transversal. But if you are getting any one pair of the corresponding angle, suppose PQB is equal to QRD, then AB will be parallel to CD. Okay, agar PQB and QRD is one pair of the corresponding angles and they are equal, then AB is parallel to CD. Or you can say if BQR is equal to DRS, then also AB is parallel to CD. Or PQA is equal to QRC, then also AB is parallel to CD, as well as AQR and CRS are parallel, then also AB is parallel to CD. So 6.4 speaks about how to prove parallel lines. So if transversal intersects two lines such that a pair of corresponding angles is equal, okay, अगर कोई भी चार पेयर में से एक पेयर इक्वल है, then the two lines are parallel to each other. So this axiom 6.4 we can also say it is the converse of corresponding angles test. Axiom 6.3 we can also call it is a corresponding angles test, and axiom 6.4 we can say it is a converse of corresponding angles test. Hope you have understood both this axiom 6.3 and 6.4. Now after this we will be studying theorem 6.2 to 6.6. Okay, let us see now theorem 6.2. If transversal intersects two parallel lines, then each pair of alternate interior angles is equal. So what is the meaning? AB is parallel to CD and PS is a transversal intersecting AB in point Q and CD in point R. Then what you have to prove? Then each pair of alternate interior angles is equal. So given I have written, to prove you have to prove that each pair, so AQR and QRD is forming one pair of alternate interior angles. Second pair BQR and QRC is the second pair of alternate interior angles. We can prove any one. We will prove first. Okay, see here. Angle AQR is equal to angle BQP you can call this result number 1. Reason, they are forming vertically opposite angles. You can say AB and PS is intersecting in Q, then we are getting here AQR and BPQ, vertically opposite angles. Okay, also AB is parallel to CD. Also angle PQB, angle PQB is equal to angle QRD. You can call this 2. Reason, AB is parallel to CD, therefore this forms a pair of corresponding angles, and corresponding angles are equal when lines are parallel and intersected by a transversal. So you can write here corresponding angles. Okay, now what you can say from 1 and 2? See, the right hand side is BQP of 1 and second PQB. BQP and PQB are one and the same angles. Okay, so from 1 and 2, from 1 and 2 we get angle AQR is equal to angle QRD. Correct? So we have proved the first one, that is one pair. Similarly we can prove the second one. So similarly, okay, similarly we can prove angle BQR is equal to QRC. No need to prove, we have to write this statement because it will be on the similar lines, that's why. Okay, hope you have understood this theorem. Let us see now theorem 6.3. 6.3 is converse of 6.2. So in 6.2 what was given? AB and CD are parallel. Okay, 6.3, see, if a transversal intersects two lines, transversal PS is intersecting line AB and CD, though they are looking parallel, we have to prove here AB is parallel to CD. Okay, for the sake of drawing diagram I have drawn parallel lines. It is not necessary that you should draw this parallel only. Okay, so such that a pair of interior angles is equal. Okay, if AQR is equal to QRD or BQR is equal to QRC, any one pair of alternate interior angles is equal, you have to prove that lines are parallel. Then the lines, two lines are parallel. So you have to prove two lines are parallel. Given PS is a transversal intersecting AB and CD. Also AQR is equal to QRD. We have to prove that AB is parallel to CD. Okay, let us see the proof. Angle AQR is equal to angle BQP. You can call this result number 1 and reason, vertically opposite angles. Okay, but what is given to you? But angle AQR is equal to angle QRD. This is given to you, so we will write here given. Now see from 1 and 2. So from 1 and 2 what you are getting? From 1 and 2 we get angle BQP is equal to angle QRD. Now if you see BQP and QRD, they are forming which pair of angle? They are forming corresponding angles and they are equal, we proved. Therefore AB is parallel to CD by axiom 6.4, by axiom 6.4, or you can say by converse of corresponding angle test. So that is angle PQB is equal to angle QRD. Okay, so Therefore, so what it implies? So it implies that AB is parallel to CD by which test? By corresponding angles, converse of corresponding angle test, by converse of corresponding angles test, or you can write axiom 6.4. Better to avoid axioms, you should write this statements only, it is better. Hope you have understood this theorem 6.3. Let us see theorem 6.4. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. So transversal PS is a transversal intersecting AB and CD. AB and CD are parallel lines. Then you have to prove that then each pair of interior angles on the same side of the transversal is supplementary. So you have to prove angle AQR plus angle CRQ. So AQR and CRQ are forming interior angles and their total is 180. When it is 180, if the lines are parallel, then only. So this you have to prove. Similarly, you can prove BQR plus QRD is 180. Okay, let us see the proof. We will prove the first part. Second part, similarly we can prove it on the way we will prove this. Okay, let us see. Angle AQP plus angle AQR, they are forming linear pair. Okay, you can call is equal to 180. You can call this result number 1. And here you can write linear pair axiom. Reason. Okay, linear pair axiom. Now, also these lines are parallel. Also, angle PQA is also equal to angle QRC. You can call this result number 2. And AB is parallel to CD, therefore PQA and QRC are forming a pair of corresponding angles when intersected by a transversal. So you can write here reason corresponding angles. Okay. Now, from one end to what you are getting? You are getting PQA is equal to what is QRC. What is our target? Our target is AQR plus CRQ is 180. So we are having result number 1, AQR is there. Can we replace CRQ by PQA? See here, QRC and PQA. Okay, so we will replace from 1 and 2. So from 1 and 2, we get, now see carefully, AQP and PQA are one and the same. So we will replace by PQA, AQP by QRC. Okay, let us, so we can write QRC plus angle AQR is equal to 180 degree. That is angle AQR plus QRC and CRQ are one and the same. Here we have written CRQ, so I am writing it that way. Angle CRQ is 180 degree. So we proved this. On the same lines we can prove the second part. So similarly we can prove angle BQR plus angle QRD is equal to 180 degrees. Hope you have understood this theorem. Let us see theorem 6.5, converse of 6.4. If a transversal intersects two lines, such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Here you have to prove that AB is parallel to CD. What is given to you? Transversal is intersecting AB and CD in points Q and R, and a pair of interior angles on the same side of the transversal is supplementary. A pair. So I have taken one pair. Angle AQR plus angle CRQ. These are the interior angles and they are supplementary. You have to prove that AB is parallel to CD. See the proof. Angle QRC plus angle QRD is 180 degrees. Result number 1. You can write here linear pair axiom. Okay, yes. Now, but what is given to you? But angle AQR plus angle CRQ is 180 degrees. Result 2. Reason you can write, it is given to you. So from 1 and 2 what you are getting? Right hand sides are same. So from 1 and 2, if the right hand sides are same, we can equate the left hand sides. Angle QRC plus angle QRD is equal to angle AQR plus angle CRQ. Okay, see, QRC and CRQ are one and the same, so they are on both the sides, left side, right side, so it cancels out. Okay, so what remains? So what it remains is angle QRD is equal to angle AQR. So AQR and QRD, they are forming which pair? They are forming alternate interior angles, and we have proved alternate interior angles are equal. Therefore, it implies that AB is parallel to CD. Okay, if a pair of alternate interior angles is equal, then the lines are parallel. So reason you can write here, by converse of alternate interior angles test, or you can write theorem 6.4, but better to write in words. You may feel that writing theorem number or axiom number is okay, but it creates a problem if you forget it. Hope you have understood this theorem. Let us see a new concept and a theorem based on it. Lines parallel to the same line. Theorem is given, lines which are parallel to the same line are parallel to each other. I have drawn here line AB, CD and EF. Okay, so what is given? I have written CD is parallel to AB. Also EF is parallel to AB. So CD and EF both are parallel to the same line. Then you have to establish the relationship between the CD and EF, that they are parallel. So you have to prove that CD is parallel to EF. Lines which are parallel to the same line are parallel to each other. Construction. What construction? We have to draw a transversal. That only I have written. Draw a transversal PT intersecting lines AB, CD and EF in points Q, R and S respectively. See the proof. Okay, AB is parallel to CD. AB is parallel to CD and PT is the transversal. PT is the transversal. Then what will happen? Okay, therefore angle PQB is equal to angle QRD. Result number 1. Now your lines are parallel, so PQB and QRD are forming corresponding angles. So we will write here corresponding angles. Okay. Similarly, Similarly, AB is parallel to EF. AB is parallel to EF and PT is a transversal. Okay, therefore angle PQB is equal to angle RSF. Okay, you can call this result number 2. No need to write the reason corresponding angles when you are writing similarly. If you write, it's okay. So from 1 and 2 what you are getting? So from 1 and 2 we get, see, left hand side and left hand side of left hand side of 1 and 2 are same, so therefore you can prove, therefore we get angle QRD is equal to angle RSF. What is QRD? If you consider CD and EF and you are getting PT as a transversal, then we have proved QRD is equal to RSF. What is the meaning? CD is parallel to EF. It implies that CD is parallel to EF. The reason you can write by converse of corresponding angle test, by converse of corresponding angles test. Okay, yes, or you may write axiom 6.4. Okay, hope you have understood this theorem.